right, one last part of 9.2. Let's see how this all relates back to a word problem. In order to change their electrical properties, semiconductors are heated in a process called furnace annealing. The pH of an acid bath used to treat a semiconductor after it emerges from an annealing furnace is supposed to be 3.5. However, the pH can cover a range of 3.45 to 3.55 without the semiconductor being rejected. The pH is given by the formula pH is equal to negative log base 10 of C, where C is the concentration of the acid bath. Okay, that sounds important. Find the range of the concentrations of the acid bath within which the semiconductor treatment is acceptable. Okay, so C is the concentration of the acid bath. We've got this equation here. P of H is equal to negative log base 10 of C. We need to figure out, we know that pH is acceptable not just at 3.5, but anywhere on a range from 3.45 to 3.55. So this is a pH here. So I've got 3.45 to 3.55. So then what exactly do they want me to do? Well, it looks like they want me to find the range that the concentrations of the acid bath are acceptable. So the C's that will spit out this range of values. Does that mean I need to find everything from 3.45 to 3.55? No, I need to also find a 2 range. So let's start with the bottom of this range here. If my pH, the lowest acceptable one, is 3.45, what concentration is going to give me that? So we're here now. All right. Now don't be confused. There is no such thing as a negative log. There's just no such thing as a negative log. Just like there's no such thing as a negative x. Negative x is not a thing. We have negative 1 times x. So that's what we also have here. So I'm going to get rid of that negative part simply by dividing by negative 1. We get log 10 of C. All right, so now what do we do? Well, this is a log. I got to get the log out, right? I'm trying to solve for C here. You don't really solve for logs. What is this statement saying, though? It says that the exponent on the base of 10 is negative 3.45, and that will give me C. So if I rewrite this, 10 to the negative 3.45 is equal to C. What is 10 to the negative 3.45? Let me grab my handy-dandy calculator here. We get a very small number, 0.0003548, blah, blah, blah. So we'll round it off to there. Now, does that make sense? Well, this is a concentration of an acid bath. One would hope that you're dealing with very small amounts of acid. So yeah, I think that sounds pretty good. That would be the bottom half of our range here. So we'll say from 0.00035 concentration. What's the top of our range here? Let's repeat this process with 3.55. So 3.55 is equal to negative log, sorry about that, 10C. We've got, again, no negative log, so we will have to divide by negative 1. Almost exactly the same moves as last time. Negative 3.55 is equal to log 10C. Again, we'll undo it. 10 was the base. Oops. That is now the exponent, and that is the answer. So 10 to the negative 3.55 is equal to C, aka... very similar. Again, we see lots of zeros, 0, 0, 0, 2, 8, 1, 8, 3, 8. So we'll just round it off to 2, 8. And that will be the high concentration. So now, obviously, one of these numbers is bigger. It looks like our range actually ends up inverting, so we don't want to write that way. We are going to say from 0.00028, which would actually give us the higher pH, to that as our final answer. And you could put 2 in between. You could put a dash like I did. You can make it an interval. However you want to write it. It doesn't actually say how you wanted to do that. All right. This is just one example of where logs is used. Logs are used a lot of different places, as we will see in a couple of the next sections. But I'll see you there.